Our next entry is on functions and relations. And in this entry you're going to have more doodle notes. Again, I'm not going to doodle on mine, so all the information that's on my doodle notes page is information that you absolutely have to write down. And this one is two-sided, okay? And it should come in the packet for functions and relations with all the things you'll need for this entry. So our entry is actually titled Functions and Relations. Okay, and that's the next entry in our book, right after the point-slope form, functions and relations. And what we're going to end up doing is cutting out this double-sided piece and cutting out these margins and taping it right here so we can flip it up, see both sides. So before we talk about functions, we really have to talk about relations. Now, relationship is just, in vocabulary, when things are related, it means they're joined. They have something in common, right? They're together. Two people in a relationship, or I think that's probably the best way to describe it, when two people are in a relationship. So, for example, the big relationships that we talk about in math are x's and y's. Those are related. They're pairs. They're related because they're on the same coordinate plane. 0, 0. That's a relationship between x and y. 1, 3. Relationship between x and y. 2, 6. Right? These are all relationships. Now, a function is a very specific type of relationship. So a function is a relationship with one or more variables, like x and y, where each input has a single output. So single is like one and only one. It doesn't have two outputs, it doesn't have three outputs, it doesn't have four. Okay? And when we start talking about this idea of inputs and outputs, what you want to think of as a function is a kind of machine. Okay? So this is kind of our function machine. And there are different parts of the machine. Okay? This part here, okay? Well, this is the domain. Okay? And domain is the input. Domain, that's where we input things into the machine. The domain are those input values that we stick into this function machine. Okay? And those input values are always the x values. Okay? And if you have a word problem, sometimes they don't use x as a variable, so you can think of a domain as an independent variable. And independent variables, that's a variable that doesn't rely on anything else. When we start talking about dependent variables, you'll start to kind of get an idea of what independent is. It's often easier to talk about dependent first. So the idea of this function machine is we have some input values, those are x values, and when we input them into our machine, okay, we get some output values. Whenever I think of function machines, I start to think of that Dr. Seuss story, The Sneetches, where the Sneetches, you know, half of them had stars and half of them didn't have stars, and half the Sneetches, you know, they wanted stars so they could be with the Sneetches that had stars. And so what they did was they went into this big machine, and they went in the machine, and the machine gave them a star. So when they came out, they had a star, right? If you keep going further in the story, well, then they didn't want a star anymore, so they went in the machine, Machine took off the star, right? So that's how I think of a function machine, kind of like that story with the Sneetches by Dr. Seuss. So we've got input, we've got output. Those output are the y values. Okay. And this is also called the range. Okay. So domain is this set of input values. So if you look at a table, right, domain are these x values, that's 0, 1, 2, 3, 4. Those are all going to be the domain. The range are the y values. 0, 3, 6, 9, 12. You just kind of list them off. Those are all the ranges. Right? That's the range, those y values. And again, if you're talking about a word problem, they don't often use the y value. They might use a different variable. So we can say that that's the dependent variable. And we call it dependent because it depends on what we put into our machine. So the dependent relies on the independent. Whereas the independent, it doesn't matter what this value is, right? Independent, it's its own number. It doesn't matter about anything else. In word problems, often time is independent because time doesn't rely on anything else. It's just always going. So that's our first part of functions. And to kind of go along with this definition, functions, each x value, and this is very important, each x value is only allowed to correspond, that's like match, right? That's like a relationship. It's only allowed to correspond to one y value. And as we start talking more about functions, you'll start to really understand what makes a function and what doesn't make a function. As we go further down the page, we've got some example problems that you'll be asked to do. It says this relation is a function because none of the input values, which are the x values, has more than one different output, those y values. So that means that 0 goes to 0. Nowhere else does 0 go to another number. Right? 0 only goes to 0. 1 goes to 3. Does 1 go to any other number? Right? 2 goes to 6, nothing else. 3 goes to 9. 4 goes to 12. Okay? So this is a function because all these x values only have one y value that they go to. So what makes something not a function? This one down here. Okay? So this one's not a function because, take a look at -3. -3 goes to 1, but it also goes to -1. It can't do both. Right? If we were to put -3 into our function machine, right? Well, we've got one input. How does the machine know what to put out? Is it going to put out 1, or is it going to put out -1? The machine doesn't know. So that makes a relation not a function. Okay? It's just a relationship, but it is not a function. So it's this one right here. Right? -3 can't go to 1, and -3 can't go to -1. Now 2 goes to 5, 5 goes to 2, that's all okay. 8 goes to -2, yep, 8 doesn't go to anything else. So these three values are fine, but it's the -3 that makes this not a function. And a nice thing to have for your notebooks for next year when you're in algebra is if you take a look at the function notation is something that we go over in algebra. So when dealing with functions in algebra, you're often going to see this symbol. in f, and then an x inside of parentheses. We treat that as the same as a y, which is the same as kind of an output of those y values. And to say that out loud, it's actually called f of x, right? F of x. And what that just says is that my function is named f, and the values I put in are x values. Okay. An example of how we use function notation is right here. To evaluate a function for a particular x value, you just plug in and then simplify. Okay? So in this example, if my function f of x equals 2x plus 1, and you're asked to find f of 3, you can kind of think about this machine, right? In this machine, and don't write this, okay, but let's say this machine is called f. Okay? And when I put in these x variables, I'm going to multiply it by 2 and add 1. So if I put in 3, 3 goes in, what does my function do? It multiplies 2 by 3, gives 6, adds 1, that's 7, and it outputs 7. Okay. Now if you don't have this nice little design, which often you're not going to have a function machine written down on your piece of paper, you're going to do it mathematically here. Find f of 3 means we're putting 3 into this function, and it's 2 times 3 plus 1, which is 6 plus 1, which would be 7. If you were to find f of 8, you would do 2 times 8 plus 1, f of a billion, 2 times 1 billion plus 1, okay? And then you just read this as f of 3, right, for function f. And that's how you evaluate functions in function notation. What we're going to do now is flip over to the back side of the page and do some more examples with functions and with relations. So in the back we have got some example problems of how to tell if things are functions or if they're just simply a relation given 4 different criteria. You might be given a table and ask the question. Set notation, okay? And set notation is just a bunch of ordered pairs. Right? You might be given a graph, and you might be given a mapping diagram. Okay, so we're going to go through these one by one, and I'm going to show you how to tell whether or not things are a function. And feel free, if you think you have it, to move ahead. Okay. But let's take a look at tables. So, review the columns. The relation will not be a function if any x values correspond to more than one different y value. Okay, so when I look at my tables here, there's example A, example B. I've got a table. -1 goes to 1. It doesn't go to any other number. 0 goes to 0. Doesn't go to anything else. 1 goes to 1. Nothing else, right? So this is a function. Okay? This one's definitely a function. So I'm going to, you can either color it in, you can shade it, but this one is a definite yes. Example B. So we've got 3 goes to -6, but 3 also goes to 6. Now 3 can't go to both, right? So this is definitely not a function. Right? Because 3 can't go to 2 different numbers. Now if this was 3, -6, 0, 1, 3, -6 again, like they just repeated this, it would be a function because 3 just goes to negative 6. They just happen to say it twice. But in this case, right, 3 only goes, or 3 does go to negative 6 and positive 6, so it's not a function. Set notation, we haven't really gone over set notation in this class, but a set is just a list of coordinate pairs, or just a list of numbers. And that list is usually in these little squiggly brackets here, curly braces if you want to call them. Okay, these curly braces. And when you're looking at set notation, okay, you're not looking at the x value, you're actually looking at the x coordinate. Okay? So you're going to review each ordered pair. The relation will not be a function if any x coordinate corresponds to more than one different y coordinate. And let's look here. 3 goes to 3, 4 goes to negative 1, 2 goes to 3. Well, that one's good. That's definitely a function. You don't see any x coordinate going to anything other than what's given, right? 3 goes to 3, doesn't go to anything else. And what about D here? We've got 1 goes to 8, 0 goes to negative 2, and 1 goes to negative 3. Well, 1 cannot go to 8 and negative 3, right? That's not possible. So this is not a function. And when you're given a graph, we actually use something that's called a vertical line test. Okay. So if we use the vertical line test, okay, which is basically just taking an imaginary vertical line, you sometimes use your pencil as that imaginary vertical line. Vertical goes up and down here, and you move it across here. How many times will it cross over this graph as I move it? Right? So here it crosses once. Would cross once. Crosses once. Crosses once. Right? What that's basically saying is that this x value here goes to this y value, and it doesn't go to any other value. Okay. Now, if I do that same test with this one, right, look what happens. Let's pretend that that's my vertical line here. It touches here and there. That's like saying this x value goes to positive 2 and negative 2, which is impossible. So when we have this vertical line test, okay, right, you want it to only cross your graph once. Here, here, right? So this one, right, that's definitely a function because it only crosses the line once. Okay. Now this one, right, this one's not a function. And it's not a function because when we do the vertical line test, okay, the relation will not be a function if a vertical line ever passes through more than one point. And when I did that on this one, it passed through here, and it passed through here, and it can't pass through both of those points. Our last one is a mapping diagram. So a mapping diagram, how to tell from that is you review the arrows. Okay, so mapping diagram uses arrows to show the relationship, to show that -2 is with 4 and 4 is with 16. Okay, so to determine if it's a function using a mapping diagram, you review the arrows. The relation will not be a function, okay, if any x value maps to more than one different y value. And let's take a very careful look at our examples here. Now, I've got -4, it goes to 16. Does the -4 go to any other number? Right? There's not an arrow that goes there, it's just 16. So the -4 is good. The -2 goes to 4, doesn't go to anything else. The -1 goes to 1, doesn't go to anything else. The 4 goes to 16, it doesn't go anywhere else. But you might be looking at this and saying, well, this -4 goes to 16, and this +4 goes to 16, so is this really a function? And the answer is yes, right? This can go to 16, and this can go to 16. What you can't have is 4 go to 16 and 4 go to 1. So it's when you have two arrows branching off of this x value that go to two different numbers. That's what makes it not a function. So in this case, even though we've got two different x values going to the same y value, that's okay. Okay? Because it's only the x value can't be mapped to more than one different y value. And you actually see that right here. 3 goes to 4, but it also goes to 16, right? 3 cannot go to 4 and 16. Right? -8 goes to 7, that one's okay. But because 3 goes to two different y values, this is not going to be a function. What I want you to do is I want you to try making your own function, the mapping diagram, okay? The mapping diagram that has your x values and your y values, and also making a graph. And I want both of these to represent functions. Okay? I want them to represent functions. For this last section here, for our doodle notes, we're going to get used to listing out the domain and the range for each of these examples, A through F. Okay. So domain, if you remember from the front, is the list of all of those x values, or those input values. And when we list a domain or we make a set, okay, we use these curly braces. So try your best to get used to making those braces. Kind of looks like a little S and then a backwards S. And if you're asked to list the domain for A, list all the x values. -1, 0, +1. -1, 0, +1. The range, that's the list of, oops, sorry, that's got to be a curly brace. The range is the list of y values. So 1, 0, 1. Now, as I start to make the range, I've got 1, I've got 0, do I really have to write the 1 again if it's already listed? And the answer is no, I don't. I don't repeat values when I make these lists because they're just a list telling you what numbers are in the range. And it doesn't matter that 1 occurs twice. We wouldn't want to repeat that because it's like repeating what you've said. You've already told the reader that 1 is in the range. You don't want to tell them again. Okay, and I want you to try B. So you can pause the video, list off the domain and the range for part B, for example B. Now let's do C. So C, again, the domain is going to be the X values. And it's a little bit harder here because we're actually given points. Okay, we've got this X value, this X value, this X value, right? 3, 4, 2. Those are going to be our domain. 3, 4, 2. In the range, well, 3, -1, and 3 again. So 3, -1, and just like this one, I'm not going to rewrite 3 because I've told the reader that it's already in the range. Now, E is going to be a little bit trickier. This is more for algebra when we start talking about domain for here. But the domain for E is these X values. And the X values, if this goes all the way up with the arrow and all the way up with the arrow, those values are infinite, right? It goes from negative infinity to positive infinity, because these arrows are going to keep going and keep going. So when you actually list the domain for E, it's going to be all real numbers. And you can even say negative infinity to positive infinity. The range you might be thinking, well, is it just infinity again? Actually, the range are the Y values, and you'll see that there are no Y values below -1. Right, so it's actually -1 to positive infinity. That's my Y value range. Right? Goes from -1 to positive infinity. So it's not all the real numbers, right? It's just -1 to positive infinity. Now, you've tried B, you're going to try D, and give F a shot, okay? And kind of think about infinity, right? And where those numbers are on the graph. Remember, this is the X values and the Y values. And when you're done, show your teacher so that they can check their answers. Okay. And oh, you know what? We didn't fill in these two spaces, but we did talk about it. Right? Domain is a set of X values. Range is a set of Y values. Now that you've finished your foldable, your doodle notes, you're going to cut out those margins, and in your book it's going to be just like we did standard form. Okay, and we just put a piece of tape here so that we could still flip the page and see both sides. We're going to do the same thing for functions and relations. You're just going to take a piece of tape, And you're going to tape just that one side to the book. So that it flips and you can see both sides. Okay, and you see how it kind of cuts off the title, so I probably should have written the title a little bit up here more. So I'll erase it and do that. And you can do the same if you made the same mistake. And your next step is to practice relations and functions and keep on going with the different portions of the website.